Hello, Year 9, and welcome to the new topic starting today. And this whole topic unit is going to be based on the Earth's atmosphere. So we're going to be learning about the history of the Earth's atmosphere, its current composition, and then we're going to start looking at ways in which the atmosphere is currently being damaged. So we're going to start looking at climate change, some of the causes, and what is actually happening there. But to start with today, we're going to narrow in and just look at how the Earth's atmosphere has developed to become what it is today. So we're going to look at what it first was and then what steps were involved in order to make it what it is now. To start with though, let's do just a quick little bit of revision and reflection and answer these three questions from the previous unit. So, what is the test for hydrogen, oxygen, chlorine, and carbon dioxide? So there are 4 tests, and you need to know all 4 of them. Number 2, what does our air contain? So the air currently you're breathing, what does it contain? And then what does a catalyst do? So what are catalysts and what do they do? So pause the video and answer those questions now. So hydrogen, we do the squeaky pop test. So you capture the hydrogen in a test tube, upturned test tube, and then you insert a lit splint into that test tube and it should make a squeaky popping sound. Oxygen, again, you catch the oxygen in a test tube, either an upturned test tube or, depending on the experiment, you can just use a test tube where the reaction is taking place, and you insert a glowing splint. So you basically light a splint so it's on fire and then blow it out and it will still be red and glowing. You then insert that splint and it will relight, or at least it will flash brightly to show it's trying to relight because it's reacting with the oxygen. Chlorine test. So chlorine test, if you have a damp piece of litmus paper and put it over the mouth of the test tube where the chlorine is coming out of, it should turn that litmus paper white or bleach that litmus paper white. And then carbon dioxide test. If you bubble the carbon dioxide through lime water, it will turn cloudy. So it will go from clear to cloudy. What does the air contain that we breathe? It's about 78% nitrogen and 21% oxygen. And then there's carbon dioxide and argon. And then everything else is pretty much less than 1%, so you get lots of trace elements, so very, very small amounts. But the main 2 are nitrogen and oxygen. And then lastly, what does a catalyst do? So a catalyst creates a lower alternative energy pathway. So it lowers the activation energy required for the reaction to occur, which then therefore increases the speed of the reaction. So it's just a bit of revision. And now let's jump into the formation of the Earth. So the Earth formed somewhere between 4.5 and 4.6 billion years ago. And it was just this mass of lava and volcanoes and roiling Earth. Daylight hours were about 6 hours because the moon was incredibly close. And so it was just lots of heat energy, and it was just this unlivable molten mass, basically. So there wasn't an atmosphere then at all. But then all these volcanoes started to form as the surface cooled. And then these volcanoes, or any volcanoes, because they still do it now, they produce large volumes of gas. So they release lots of carbon dioxide, lots of steam, and lots of ammonia. And they release all of that into the atmosphere. So as it started to cool, these volcanoes formed and started pumping these gases into the atmosphere. And then because of gravity, these gases stayed near the Earth and formed the earliest form of an atmosphere. So the earliest form of an atmosphere was mainly filled with carbon dioxide, steam, and ammonia, made from volcanoes. Then, as it cooled even more, this steam in the atmosphere starts to cool and condense. And why do I have a picture of a cloud there? Because that's what it is. It is water vapor cooling, condensing, and then eventually it will then rain, and that liquid water will fall. And then rains, they form oceans, they form lakes and puddles, but eventually all of that water finds its way into the oceans. So this liquid water or liquid water vapor, so this water vapor that formed from these volcanoes eventually cooled down, condensed, and fell back to the earth and formed the oceans as liquid water. So then some of that carbon dioxide in the atmosphere dissolves into the oceans. Now, this is a process that happens today as well. Right? A lot of the carbon dioxide released in the Earth's surface or trapped in the Earth's surface actually exists as dissolved in the ocean. So there's lots of carbon dioxide dissolved in the oceans, and still lots of carbon dioxide dissolves in the oceans. So it's a process that happened billions of years ago, but also still happens today. Okay, so this carbon dioxide in the ocean creates formations of carbonates on the ocean floor. Now, carbonates, the main type of carbonate is a limestone. And so this then atmospheric carbon also gets trapped in rocks as well. So these carbonates trap carbon dioxide in rock form, but then there's also carbon dioxide dissolved in oceans. So the next step in it is that parts of the carbon dioxide in the atmosphere are being dissolved in the ocean and also trapped in rocks as limestone or carbonates. Then we get to life. So about 3.4 billion years ago, we have the first life forms developing in the oceans. So they had to develop in the ocean, not on the Earth's surface, because the Earth's surface didn't have any form of atmosphere that could protect it from the ultraviolet radiation coming from the sun. So if anything tried to exist or life tried to form on the Earth's surface, it would almost immediately die due to the ultraviolet radiation from the sun. So that's really important. That's why life developed in the ocean, as well as the fact there were lots and lots and lots of minerals and other elements. You can almost call it this like organic soup, which is why life developed in the oceans. So life started developing in the oceans. It was very simple plant life to start with, bacterial life. And they used photosynthesis to produce oxygen as a waste product. And so these organisms started taking in some of that light and some of the carbon dioxide that dissolved in the oceans, and obviously water from the oceans, and then they produce oxygen and glucose. So this photosynthesis started producing reducing or removing carbon dioxide from the atmosphere, and then these hard shell creatures, when they die, they also become sediments or more carbonates or limestones, thus for trapping more of that carbon dioxide or carbon in the oceans. So you've got carbon being trapped in water and rocks, and now in these dead organisms are trapping carbon as well. So see this process here, we're reducing the amount of carbon dioxide in the atmosphere and increasing other elements. Because if you think about photosynthesis, it produces oxygen. So that oxygen then starts to find its way into the atmosphere. So some of it's converted into ozone, which is O3, so 3 oxygen elements, or atoms, joined together. And this formed an ozone layer in the upper atmosphere. So this ozone layer is really important, and was really important back then, and it's still really important for us today, because it actually blocks the UV light from the sun, and then that allowed the life on the ocean floor to actually move onto land. So that development of the ozone layer meant life could move from the ocean floor onto land. And then that increased number of plants thus also then started to increase the amount of oxygen and decrease the amount of carbon dioxide. So you think about it, you still got lots and lots of carbon dioxide and not much oxygen. And so things started to shift. Those plants started to take in all of that oxygen, all of that carbon dioxide in the atmosphere, or what was left of it, and turn that into oxygen. So if we think about a plant photosynthesis, okay, it takes in carbon dioxide and then it also takes in water, both of which are very abundant, and then it uses that energy from the sunlight during photosynthesis to create glucose and oxygen. So it's releasing all of these oxygen atoms into the atmosphere and then also making all this glucose. So these plants, they started to colonize the surface of the earth and take over the surface of the earth. So therefore, they started creating more and more and more oxygen, which made it much richer in oxygen. That then allowed animals to develop, because the animals can't create their own food like algae and plants. They can't photosynthesize these animals. So what they relied on was the algae and the plants to eat. And then they also relied on the oxygen to respire. So if you think about humans, we eat plants, we breathe in the oxygen that plants form. So these two relied on each other. So these animals were relying on these plants producing oxygen and producing glucose in order to survive. So that's how the first animals started to develop. Sorry, slightly frozen here. And then last but not least, so this ammonia that was produced by the volcanoes, it reacts with some of the oxygen and it produces water and nitrogen gas. So then life forms such as bacteria are also able to break down ammonia and produce nitrogen. So that's why we've got lots of nitrogen in the atmosphere currently. If you remember at the start of the lesson, I said there's lots and lots of nitrogen still in the atmosphere. This is why. That ammonia was reacting with the oxygen to produce water, and therefore what's left from that is nitrogen gas. So we were producing lots of nitrogen gas as well, which is why there's lots of nitrogen gas in the atmosphere currently. So currently about 78% nitrogen, 21% oxygen, 1% argon, 0.04% carbon dioxide, and then the others are so small they're pretty much almost not there if you look at the total composition of the atmosphere. So the atmosphere is pretty much what this is today and was formed after all the plants and animals. So here's a number of YouTube videos to watch at the end of this lesson, which kind of give you a bit more of a foundation of how we know about the history of the atmosphere and also the formation of the Earth. So there's some really good videos to watch here. And then also what I'd like you to try and do to the end of the lesson is create a comic strip to show how the atmosphere on Earth has changed. So I've got one here which kind of gives you a bit of a summary as to what is going on and what it should look like. So starting off with the early Earth and then why the first few gases formed and how from volcanoes, and then the fact that all that then water vapor then fell to the earth and formed oceans, and then within the oceans you had life start to form which produced oxygen, and you've also got carbon dioxide being stored in the oceans, and then from that the oceans then produce the ozone layer, which then means that plants can move onto land, and then animals start to develop and therefore take in some of that oxygen and release carbon dioxide. And you've also got the ammonia reacting with oxygen to produce water and therefore leaving nitrogen. So they're all the things you need to put in your comic strip. So at the end of the lesson, hopefully You'll have watched some of those videos on the previous slide. Head over to Edulink to find the links to them. And then you'll also have created a comic strip of the history of the Earth's atmosphere. Enjoy this task, guys. Take care, and I will talk to you tomorrow.